Day 2, simplifying expressions and solving equations using the distributive property. So, first let's talk about the distributive property. The distributive property is adding a sum by multiplying each term separately. You distribute the multiplication. So, just as a little bit of background, let's talk about that word term again. The word term. Terms are defined by being separated by an addition sign or a subtraction sign. So everything that has an addition or subtraction in between it is considered a term. So rather than me going through this and making this super difficult, let's first look at it in kind of a weird way. So let's imagine that I had a heart on the outside of a set of parentheses with a box and a circle on the inside. This heart is multiplying times everything inside of that parentheses, meaning the heart is multiplying times the box as well as the circle. Sometimes that will be denoted by an arrow like this. Some people use these arrows to help them keep track of things. I'm going to write the arrows in so that way you guys can help keep track of this until you get comfortable with it. So if I have that heart on the outside of the parentheses, it multiplies first times the box and then times the circle. But what sign was that circle carrying? Well, had a plus in front of it, so it's going to keep that plus. So heart times box plus heart times circle. Those two statements on either side of this equation are equal. They're the same. So one way is a simplified way of writing it, right? Because we don't have hearts all over the place over here. We call that simplified. And one is the expanded form. So let's take a look at example number 2. A times parentheses B plus C. Okay, so here I would take my A and multiply it times the B and the C. So here and here. A times B plus A times C. Okay, good. So now let's look at example number 3. 3 times 4 plus 10. Okay, so because these are all numbers, I could combine what's on the inside to 14 and then multiply it times 3, right? PEMDAS, parentheses, exponent, multiplication, division, addition, subtraction. I could do that, but for the purposes of this demonstration, I'm going to distribute it and pretend like they're variables for the first step. 3 times 4 plus 3 times 10. 12 plus 30, 32. So that means 3 times parentheses 4 plus 10, is 42. All right, let's take a look at the next one. 2 times x minus 2 times 7. So 2x minus 14. Okay. So let's talk about the steps that are usually involved in this. Step 1, we always want to get rid of the parentheses. People sometimes just say distribute. Get rid of the parentheses. We can draw a line in front of every sign in order to help us separate them. and then we can combine like terms. Remembering that sometimes I don't draw the line, I like to do my shapes just to kind of help me stay organized, okay? So 7 times x, 7 times negative 5, 7x minus 7 times 5, 35. And nothing is distributing over here, so I'm going to copy it over because nothing happened, right? Okay, so now I'm going to look and see if I can combine like terms. So 7x, there's no other x's, so that's fine. I'll leave it there. And I'm going to change my color just to help us keep track. Let me cross that off. Now I have negative 35 plus 12. So I'm going to combine those to negative 23. That's my final solution. All right, let's move on to the next one. Now this one's a little tricky. They threw in all of these negatives. Now, a lot of times people get super confused by this, okay? As a side note, I'm going to say something that will help you understand this better. Negative just means opposite. So for example, if I said negative 2, that's really just the opposite of positive 2. Now, in the case where somebody just writes negative anything, you can automatically assume that that's a 1. Negative 1. We just don't write it in, okay? So that means I can take negative 1 and multiply times everybody on the inside of the parentheses. I can also think about it like this. That just means changing to the opposite. If they're positive, they become negative. If they're negative, they become positive. So I'm going to start by first copying over my 3x. That guy's not going to change, so I'm going to leave him be. So negative 1 times negative 2x plus 2x. Negative 1 times positive 8 minus 8. All right, we got all of those. Let's combine like terms. 5x minus 8. Final answer. Now, this also works the same whenever we're solving equations. What we have to do first is just get rid of the parentheses, okay? So sometimes our notes that we use will have steps outlined. So always, we're going to distribute. Let's get rid of those parentheses. They look so confusing. Let's just get rid of them. We can draw a line in front of every sign if we need help kind of discerning where each of our terms are. Then, of course, we're going to combine like terms to keep things simple. And then we're going to use inverse. That's my fancy word for opposite. Operations to isolate my variable. So what does that mean? That means x likes being alone. And whenever I think about solving an equation, I say, well, what does my answer look like? Stereotypically, I'll say my answer looks like x equals something. So everything else is going to be on one side, x is going to be on one side by itself. Okay, so let's look at example number 7. So here they gave us some distribution inside of an equation, and there's negatives all over the place. So I'm going to make sure I'm going to keep myself straight by ensuring that I take this slow and make sure and write out my stuff. So first let's start with this distribution because I hate dealing with parentheses. 4 times negative 3x, negative 12x, 4 times positive 7 plus 28. Okay, I'm done with my parentheses. I'm going to cross all that off because I'm done with it. The equal doesn't change. My negative 32 doesn't change. All right. So now I see that I'm here. I need to get the x by itself. I'm going to go ahead and highlight him just to help me out. So everything that's outside of that highlight area I need to get rid of so it can be by itself. Usually, every single time you're solving an equation, the very last two steps are going to be what I call exciting move, great divide. I'm going to move something and divide something. I always move whatever is not attached to x and then divide by whatever is attached to x. Okay? Let me just write that off to the side. Exciting move, great divide. So exciting move, I'm going to look over here. What is not attached to my x, but on the same side? That's at 28. Let's move that guy. I'm using the inverse operation, my opposite operation. That's positive 28, so I'm going to subtract 28. And I've got to do it from both sides. Why? Because I have this equal sign, which means I want to keep it equal. Okay, so I got that. All right, nothing changes here. Equal sign doesn't change. These guys are going to cancel. And then over here I have these two negatives. Let's go ahead and combine them. Okay. All right. So now I still need to try and get this x by itself. What do? Well, I need to get rid of that coefficient. Technically, when I see two things, I refer to them as backed up on each other, attached to each other, with nothing in between them. I don't see a plus, I don't see a minus, I don't see a division sign. They've got to be multiplying. So in order to get rid of that negative 12, I must do the opposite of multiplying, which is dividing. Divide by negative 12, divide by negative 12. So x, all right, I got it by itself over here. X is equal to negative 60 over negative 12. So negatives, they cancel. 60 over 12. I don't know what that is. So I'm going to reduce. So I'm going to just keep dividing by 2s, 3s, simple numbers until I get it small enough to see something that I know. 60 divided by 2, 12 divided by 2. Let's do that again. Divide by 2, 15 over 3. Oh, that's 5. So my answer is x equals 5. All right, example number 8. Here they threw a couple more negatives in there. They threw all kind of extra stuff, but I'm not going to sweat it. This is simple. All I have to do is make sure that I follow the same steps. Distribute, combine like terms, inverse operations, get my variable by itself. Okay, so first, let's distribute. I'm not dealing with anything besides the stuff that is inside and attached to my parentheses. Everybody else stays the same. So 5x, he's over here, might equal my 163. All right, we got all of those. Negative 3, because remember, these come together as a unit. Negative 3 times negative 2x, okay? So whenever we're multiplying things that are together like that, we do number to number, variable to variable. So negative 3 times negative 2. Well, negative times negative, that makes positive. All right. 3 times 2, that's 6x. Okay, got that one. Let me cross that off so I don't get confused. Negative 3 times negative 14. So negative times negative, positive. 3 times 14, that's 42. And we got that. All right, we got rid of those parentheses. We have distributed. Now let's go ahead and make sure there's nothing we can combine. So first I'm going to look on this side. That 163 is by itself. I'm not even going to bother it. Now I'm going to look over here. Okay. First thing I'm going to say is, all right, which one comes first in the alphabet? Well, lucky me, I only have x's. Okay? Do they all have the same exponent? They do. Good. It's only x to the power of 1. We don't write that one in. So I'm going to go ahead and combine those. So 5x, 6x, that becomes 11x. All right. 42 is not going to change. I'm going to copy it over. Equals not going to change. 163 is not going to change. Okay, good. Got that. So now I need to that I've gotten all of my x's together. They're all in one big giant space. There's 11 of them together. I need to get it by itself. I got to get rid of all the things that are around it and on the same side. So it looks like it has an 11 that's attached to it, multiplying, and a 42 that's not attached, a constant. Okay. So I could go ahead and get rid of the 11 and divide everything by 11, but boy, that looks crazy because that's going to start making all kind of fractions. I don't want to deal with all that. So instead, I'm going to follow that same exact thing. Dividing move, great divide. I'm going to move something first. Let's move this 42. All right, we made it somewhere. Okay, so I still have that 11 multiplying times that x. So opposite of multiplying is dividing. Okay, x is equal to 11. We have a final answer. All right, so that was pretty simple. All I had to do was just take my time and make sure and write it out. So I want you guys to go ahead and work on these two questions, and we're going to submit those. Remember that whenever you're dealing with fractions, there's something important to know. So let's say, for example, here I have my 2 and my 3, right? So if you take a fraction, the top part is multiplying, the bottom part is dividing. So let's say, for example, I have 4 times 3 over 2, right? I can divide by 2 or multiply by 3 first. I have to do both of them, but depending on how the numbers look, I might choose to do one or the other to keep it simple in my mind. Now, I notice here that 4 can be divided by 2 evenly, right? 4 over 2 is 2, and I get 6, right? I could have also said 4 times 3 is 12, divided by 2 is also 6. Notice, either way I get the same exact answer. So, just want you guys to be cognizant of that whenever you're dealing with your fractions. We'll be inputting these two, answer selection, and you'll be completing the rest of the work that's attached below. Thanks so much for your attention, and message me if you have any questions. Goodbye for now.